Hi, thanks everyone for being here. Hope you're enjoying demo day. I just wanted to start by sharing the fact that globally, 1 in 4 adults do not meet the recommended levels of physical activity, according to the WHO, which I can assure you are really not that hard to meet. Up to 5 million deaths a year could be averted if the global population was more active. Actually, to hone the point down, people who are insufficiently active have a 20 to 30% increased risk of death. So how do we get people moving? And I mean, humor me for a second. What if there was this insane pandemic that didn't allow us to leave the house, let alone go to the gym? You know, one that forced us to stay indoors and get active? It's even harder. I know it sounds crazy, but what then? Would we just, mindlessly rummage through YouTube finding workouts? Well, the solution is what I worked on for my fellowship project. My name's Parvathi, and as part of it, I took a stab at tackling this issue by building a fitness recommender for EastNine. EastNine is a leading fitness app, and it's on a mission to make exercise really a habit for everyone, and a platform where fitness professionals can live off their expertise. My objective was to use machine learning to recommend the best workout for you, and one that you'll incidentally love, so you'll keep on moving. How do we build this recommender? Well, first, let's take a look at the data that I was working with. In terms of the content itself, the workout, I was looking at the trainer, their duration, their workout type, its intensity, what goals it had in mind, what area of the body it was targeting. Everything that you could think makes each workout unique. In terms of the users, I wanted to understand their ages, their fitness level, their goals, their gender, how much time they have on their hands, importantly. But more than anything, I wanted to look at feedback data, what users actually like. Rather than look at the ratings, I wanted to understand what workouts users had actually completed. And after some trial and error, I arrived at a scoring system where specific completions were then converted into ratings. So let's say you'd loved a workout so much or felt you needed it so much that you'd gone ahead and done it 3 times. I could assume that you would give it a 5 stars. If you'd completed it twice, well, then it's about 4 stars. If you'd only done it once though, we really can't assume much. So it stands more neutrally at 3 stars. Now, if you started and didn't finish a workout, and it wasn't because you were just browsing, depending on your reason for leaving the workout early, you'd give it a 1 or 2 stars. To build a recommender, we could simply calculate a similarity metric amongst these 3 groups. We could just use a mathematical distance, say cosine similarity, to find the most similar workouts and the more similar users, and then recommend workouts to others based on highly rated workouts that share users or features. This technique is in fact used by a lot of recommenders today, but can we think of a more personalized way to give recommendations? How do we put all those metadata together for a more holistic model, which is what we want ideally? Well, we use matrix factorization, and we use it to build a model capable of predicting a score for each possible combination of user and workout based on existing ratings. In this case, as I explained, ratings are converted from how many times a person has completed a workout. So here we have Maria, who's completed Anya's yoga 3 times, but didn't finish JJ's strength because it was too exhausting for her. Here the model would try to predict for Labib based on what he had done before. Talking specifically about factors, very roughly speaking, individual users and specific workouts are represented by weights and also factors. This is what makes the model personalized. They're coefficients that are learned during training. Specifically, the factor terms model interactions between users and workouts. So for example, take Maria again, who tends to love yoga and really hates strength. Well, the factor terms attempt to capture that. So it will cause the model to predict a lower score for strength and a higher score for yoga and meditation type workouts. Weights, or bias terms, account for workouts that are consistently rated highly. Say here, Anya's yoga's first workout. It's really popular amongst users of EastNine, so it will have a higher weight. And conversely, another workout that's consistently rated below average would have a lower weight coefficient associated with it. But you might say, but hey, Parvathi, that only solves the problem for existing users. How do you account for users who have not rated anything, or workouts that are new and haven't been rated? Clever you, because that's an excellent question. Well, While standard matrix factorization learns latent features for users and workout interactions that we already know, the factorization machine really allows us to train our model with all available features. New users will have age and gender, and we know workout features like duration and a trainer. In other words, to make its prediction, it accounts for the interactions between all pairs of features and really solves the cold start problem, what it's called. But how do we validate this model? Well, it's really tough because the quality of road recommendation system is really notoriously hard to quantify. Just think about it. What is a good recommendation for fitness? It's quite subjective. So ideally, you need to A/B test, but offline, we can ask the model to predict a rating for a known group of users. And then we calculate the difference between that prediction and the known ratings. And as a result, our model can predict a workout that you will love to a half star and motivate you to get active. Thank you.